Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Killer Counters by Burak Alver. And here are the rules. We have Sudoku, where normal Sudoku rules apply. That is, each row, column, and 3 by 3 box must contain the digits 1 through 9 once each. We also have killer cages, where digits in cages must sum to the number in the top left corner. And so, as an example, if this were, say, a 4 here, this would have to be a 7, because these two digits are in a cage, which have an 11 in the top left corner, and 4 and 7 adds up to 11. So that's how that works there. We also have Kropki dots, where digits separated by a white dot are consecutive, and digits separated by a black Kropki dot have a 1:2 ratio. And not all dots are given. So, for example, if we had a 2 here, this would have to be a 1 or a 4 to maintain the 1:2 ratio between them, because there's a black dot between them. And if this were, say, a 6, this would have to be 5 or 7 to make sure that these digits are consecutive, because there's a white dot between them. And finally, we have counting circles, where a circle digit indicates exactly how many circles contain that digit. So, for example, say this was a 4 and a 7 here. Then there would have to be 4 4s in circles and 7 7s in circles also. Because if there's a 7 in a circle, we have to have 7 circles total with that 7 in it. So you could have something like, I don't know, 7 here, 7 here, 7 here. It's going to be hard to maintain. 7 here, 7 here. 7 there. That's 1, 2. We have 1, 2, 3, 4, 5, 6 7s in circles. So we could potentially have a 7 there. And that works, actually. So this would work because we have, in this puzzle, if a 7 appears in a circle, it must appear that many digits times, 7 times. Same with the 4. The 4 would have to appear 4 times here. So say we had like 4, 4, and that's probably not going to work, but anyways. And then we had 4 here and 4 here. So this could be valid, assuming that there are no more 4s in circles, because we have 4 4s already in circles here. And we have 7 7s in circles here. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so with these counting circle pipe puzzles, what I like to do is I like to count how many circles there are. And what that gives you, so since every digit, if it's in a circle, must appear that many times in the circle, so 1 appear once, 2 appears twice, 3 appears 3 times, etc., all the way up to 9. That's if they are in a circle. That means we could have up to 45 cell digits in circles, right? 1 1, 2 2s, 3 3s, 4 4s, 5 5s, all the way up to 9 9s in circles. But this tells us essentially what the digits in the circles must sum up to. So let's count. We have 4 in column 1, 4 in column 2, that's 8. 4 in column 3, that's 12. 1 in column 4, 13. 4 in column 5, 17. 5 in column 6, 17 plus 5 is 22. 3 in column 7, 25. 2 in column 8, 27. And 4 in column 9. 27 plus 4 is 31. Just to double check, let's count the ways in the rows. 3 plus 5 is 8, plus 5 is 13, plus 2 is 15, plus 5 is 20, plus 2 is 22, plus 4 is 26, plus 4 is 30, plus 1 is 31 again. So we have 31 circles. So that means the digits in the circles must add up to 31, right? Because they'll appear that many times in the circles. So that would mean that essentially the 31 is the total sum of all the digits, the different digits in the circles. That means the remaining, or the digits which are not in the circles, have to add up to 45, which would be the total if we had every digit in the circle, minus 31, which are the number of circles. That's 14. Okay. So, okay. Couple of things then. So, right. Couple of things. So since the digits in the circles add up to 31, we also have these cages, and all these circles, almost all of them, I should say almost all of them are in cages, which tells us something. First of all, we also know you could have digits not be in circles if we have, again, the digits that are not in circles must add up to 14. So you could have two digits not in circles. You could have 5 and 9 missing, or 6 and 8 missing, which adds up to 14. You could have three digits missing, something like 1, 4, and 9, or 3, 4, and 7, I think, add up to 14. Or you could have four digits missing, with like 1, 2, 3, and 8 missing, or like 2, 3, 4, 5, 2, 3, 4, 5 missing, or something along those lines. So we have to figure. Okay, so in this left central box, we have 5 digits in circles, but they only add up to 8 plus 18, which is 26. So that means we know we cannot have 4 digits missing, because if we have 4 digits missing, these 5 other digits are the only digits in circles. But then you would not add up to 26, you would have to add up to 31, which are the number of circles we have total. And it's the same thing here. We have 28 missing. We have 28 here. So we're missing either 3 digits or 2 digits, adding up to 14 in circles. Okay. If we have a 9, well, Oh, okay, gotcha. Perfect. We have 2 digits here in circles, and they add up to 16 as a cage. The only 2 digits which can ever add up to 16 as unique digits is 7 and 9. So we have to have 7 and 9 here, which means we have to have a 9 in each 9 nines in a circle and 7 sevens in a circle. Well, that means 9 has to, wherever it appears in a row or column, has to be in a circle. So if we have only one digit one cell, I should say, in a row or column or box, which is the only circled cell in that box, it must be a 9. So we have to have a 9 here, because it's the only circled cell in column 4. Well, we also have the only one circled cell in row 9, which means that also must be a 9. And in every box, again, we have the same thing. So in this right central box here, we have to have a 9 in a circle. So it must be 9 here. And we continue with that. Where is the 9 then in column 9? Cannot be here because of 9's in the boxes, and it can, again, it has to be in a circle, so it must be one of those two. Where is the 9 in this left central box? Cannot be here because of 9 in the row. Can't be here because this adds up to 8, and 9 plus another digit is never adding up to 8. So 9 has to be one of these two digits here. 9 and 2, we know, add up to 11. So we have a guaranteed 2. We have two 2's in circles. So the digits we know have to be in circles are 2, 7, and 9. What else do we know? So we could still be missing two digits. It would have to be 6 and 8 specifically, because 5 and 9 is removed. That add up to 14. 3 digits is still very much possible. We're still looking for where 9 can be in these cells. 9 has to be one of these 5 cells here, has to be one of those 3 there. Okay. This is 9, so these two digits must add up to 20 minus 9, which is 11. So it cannot be 2, 9. It could be 3, 8, 4, 7, with this being 7 and that 4, or 5, 6. We're not sure. This has a 9 in it. That means, again, we have to have the two other digits be adding up to 20 minus 9, which is 11. So we have 3, 8, 4, 7, 5, 6 with the 9 possible here. 9 has to be one of these digits here. So this is 9. So this, to add up to 18 here, it can either be 1, 8, 2, 7, 3, 6, or 4, 5. So that's pretty much the entire set is possible. This adds up to either 1, 7, 2, 6, or 3, 5 here, adding up to 8. Okay. Hmm. I was thinking of something else. Never mind. This is interesting. 9 has to be here. 9 obviously has to be one of these three. Oh, this adds up to 21 with the 9. So 21 minus 9 is 12, so the other two digits must add up to 12. Cannot be 3 and 9 because we already have a 9 in the cage. So it's 4, 8 with the 9, or 5, 7 with the 9. Okay. So, one thing that's interesting is we already have... Oh, okay. We already have 8 cannot be in a circle in this lower left-hand box and this lower central box, which means 8 is guaranteed to not be in a circle because it can't be in a circle in this lower left-hand box, can't be in a circle in this box here, the lower central box. So there is no way that 8 can appear in a circle 8 times. So 8 can never be in a box, which means this cannot be 4, 8, and 9 to add up to 21. It can only be 5, 7, and 9 here. So we know 5 also has to appear in all these circles. This can't be 3, 8, and 9 here for the same reasoning. This can't be 3, 8, or 9 here either. So we're definitely missing an 8 from circles, and it's either going to be a 6 we're missing, or 1 and 5 added up together that we're missing, adding up to 6. Because 2 and 4 is definitely in a circle because we have 2 and 9 here. So that means interesting. So we're guaranteed this is either 4 or it's 6 here to add up to 20. In column 7, the only digits which can be in a 1 to 2 ratio have to be 1, 2, 2, 4, 3, 6, or 4, 8. But the 4 and the 6 being there means one of the sets. So if the 6 is here, that means the sets have to be 1, 2, and 4, 8, adding in a 1 to 2 ratio. If 4 is here, that means the sets must be 1, 2, and 3, 6. So we're guaranteed one of these pairs is 1 and 2. We're just not sure which. That eliminates 1 and 2 in the rest of the column. We also can't have 4 and 6 in the rest of the column, because if this is 4, again, that would force 3, 6 to be the other pair of digits in a 1 to 2 ratio. If we have 6 here, that would guarantee this has to be 1, 2, 4, 8 as the pairs of digits in a 1 to 2 ratio. So cannot have 4, no 1, 2, 4, 6, or 9. So this has to be 3, 5, 7, or 8 remaining in column 7. Okay. We have 5, 7, 9 here. In this central box, this right central box, this lower left-hand box, and this lower central box, we do not have 6 in a circle. That means 4 boxes cannot contain 6 in a circle, so that leaves only 5 potential boxes for 6, which means we cannot have a 6 in a circle at all. Because this is 5, 7, 9, this is 2, 9, this is 7, 9. There's no 6s in circles in those boxes, and this is only a single 9 here. That means we can never have 6 in a box. So the missing digits in circles are 6 and 8, adding up to 14. So this must be 4 and 7 here. That means the remaining digits in column that are in a column 7 that are in a 1 to 2 ratio are 1, 2, and 3, 6. This again cannot be 6 here in this cage, so it's 4, 7, and 9 also. This 1, 2, 3, 6 quadruplet eliminates 3 and 6 and 1 and 2 in the rest of the column, and the 7 eliminates 7, so this must be a 5, 8 pair. Again, 6 cannot be here, so this cannot be 2 and 6, adding up to 18, 8 here. We have 5, 7, 9 there, 4, 7, 9 here, 4, 7, 9 here. We can't have a 6 here. 7 also is not in this lower central box and this right central box in a circle. So 7 in every other box must be in a circle. That doesn't tell us very much, but we know 7 and 9 are in the circles here, 7 and 9 are in the circles here, 7 and 9 are in the circles here. Oh, that's interesting. So 7 and 9 are guaranteed in the circles here, and those circles add up to 26. Which means the remaining 3 circles must add up to 26 minus 16, which is 10. So 3 unique digits adding up to 10. We can use any of the digits from 1 through 5. We cannot use 6. And we can't use 7 or 9. Those are already counted. So it's either 145 or 235 there. Okay. Right. So if this is 3-5, this becomes 2-7-9 here. If that's the case, no 9 there, though. If this is 1-7, then this has to be 4-5-9 here. Either way, 5 is guaranteed to be in a circle here. We have 5 guaranteed to be in a circle here. Again, actually, in this lower left-hand box, the lower central box, the right central box, and the upper right box, we do not have a 5 in any of those circles, in any of the circled cells. So that means 5 has to appear in a circle in every other box. So we know 5 has to be here, which means this can't be 5, so that's 8, which makes this 5 there. 5 has to appear here in this set. We already knew 5 appeared there. We know 5 appeared there. So 5 has to appear in one of these 3 cells here. Well, if this were 5, this would be 6 to add up to 11, and that's not possible. Because, again, you can't have 5 there adding up with 6 because 6 cannot appear in circles. So we guaranteed 5 has to be here. And so 5, 7, and 9 all have to appear here. It also has to appear here. That adds up to 21. 26 minus 7, or sorry, 26 minus 21 is 5, which is why we had 1, 4, or 2, 3 as the other pairs. And here, we have 28 minus 21. We can't have 1, 6 because 6 can't be in a circle. So it's either 2, it can't be 2, 5. 5 is already counted, so it must be 3, 4 here. So we know these circles must be 3, 4, 5, 7, 9 to add up to 17, or sorry, 28 total. 3, 4, 5 is 12, plus 7 and 8, 16 is 28. And the only pair that adds up to 11 is 4 and 7 as a pair. So this must be a 4, 7 pair here. That eliminates 4, 7 in the rest of the box. So no 7 here. This is 3, 5, and 9 here. 4, 7 eliminates 4 and 7 in the rest of the column here. So no 7 here. And no 4. So either this is 2, 9, and 7 here. So 7 would be there if that's the case. Or this is 5, 9, and 4 here. Because these cannot be 4 or 7 there. Which means where's 9? 9 has to be in this cell here. Because it can't be here. That eliminates 9 in the rest of the row. So now we have a 5, 7 pair, which eliminates 5 and 7 in the rest of the row and box. So this can't be 5 or 7, it's 9. That eliminates 9 from being there. This can't be 7, so it's 4 and 5 adding up to 18. That eliminates 3, 5 in the rest of the box. So this is a 1, 7 pair. That eliminates 1, 7 in the rest of the column, so no 7 here. So this is 9, which makes that 7. 9 eliminates 9 here. Okay, so we have 5, 7 as a pair here, which eliminates 7 there, so that's 1, that's 7. Okay, 5 is guaranteed here. 1 eliminates 1 here, so this can't be 2 then. This is in a 1 to 2 ratio, and we don't have 1 or 4 available. So that means no 1, 2, no 2, 4, no 4, 8. This is 3, 6 as a pair. That eliminates 3, 6 in the rest of the row, so this can't be 3 or 6. It's 1, which is in a 1 to 2 ratio with 2, which means this can't be 1 or 2. It's a 3, 6 pair. Remaining digits in this left central box are 2 and 8. If this is 2, this can't be 1 here because of 1 in the column. If this is 8, it cannot be 9 here because of 9 in the row, and it can't be 7 because of 7 in the column. So this has to be 2 and 3 here, which makes that 8. 3 eliminates 3 here, so it's 5, which eliminates 5 in the rest of the box, and that eliminates 5 being here. So we have 3, 9 as a pair here, which eliminates 3, 9 in the rest of the column. So this can't be 3, it's 6, which means this can't be 6, it's 3. Where is the 9 in row 1? It has to be in a circle, but it can't be here because of this adding up to 11. And it can't be here because of 9 in the column, so 9 has to be there. So these two digits add up to 10. Because we have a 9 here. 19 minus 9 is 10. How many digits do we have in each set? So it can't be 1, 9 because we already are using the 9. Can't be 2, 8 because 8 can't be in a circle. Can't be 4, 6 because 6 can't be in a circle. So this must be 3, 7 as a pair. That eliminates 3, 7 in the rest of the box. So no 7 there. This 7 eliminates 7 here, so it's 5, which makes that 7. 5 eliminates 5 here, so the 5 in the circle in this box has to be there. So that's 5. We have a guaranteed 3, 9 here in rows 2 and 3 in this upper left-hand box. And we have a guaranteed 3, 6 here in column 7 in rows 2 and 3. That eliminates 3 available in rows 2 and 3 because we have a guaranteed 3 here and a guaranteed 3 here in both the rows 2 and 3. So then those are the only 3s that are possible. So this can't be 3. It's 7, which makes that 3. 7 eliminates 7 here, so it's 4 and 7. 4 and 7 eliminate 4 and 7 here, so it's 9. That means this can't be 9 here. 9 eliminates 9 here, so this is 3, which makes this 9. 3 eliminates 3 here, so it's 6 and 3. And remaining digits left in circles. So we already have 1, 1. We only have 1, 2, so 2 has to be one of them. 3, we have 2 3s. So we need another 3. And 3 cannot be here because of 3 in the box. 3 can't be here because of 3 in the row, so 3 has to be there, which leaves that as a 5. And then we have 2 left. So that must be 2. And 4 and 7, we have 1, 4 here, 2, 3, and 4. And 7, we have 1, 2, 3, 4, 5, 6, 7 cells in circles. These digits are consecutive. And we cannot have each consecutive pair is going to be an odd and an even pair, right? You can't have an odd and odd pair be one apart from each other. That just defies the definition. Same with even and even. There's always a difference of at least an even value between even digits and odd digits. So we need an odd digit here. And it cannot be 1, 3, 5, or 9 because we have 3, 5, 9 in the column and 1 in the box. So we have to have a 7, and 7 can't be here because of 7 in the row. So 7 must be here, which is consecutive with 6 or 8. 7 eliminates 7 here, so it's 4 and 7. And the rest is probably, well, it has to be just normal Sudoku. So we have all the 9s accounted for. They should all be in circles, which they are. 7, we should have 8 7s now because we have all the 7 7s in circles and then the 1 outside, which means the last 7 has to be in a certain spot. It's there. 6s are not in circles. 5s. Where is the 5 in column 2? These cannot be here because of 5 in the box. Can't be here because of 5 in the row, so 5 has to be there. Where's the 5 in column 8? Cannot be here or here because of 5's in the boxes. Can't be here because of 5 in the row, so 5 has to be there. That gives us 8, 5, so the last 5 has to be there. 4s. What about 4s? We only have the 4 4s in circles. But where is the 4 in column 8? Cannot be here or here because of 4 in the boxes. Can't be here because of 4 in the row, so 4 has to be there. Where is the 4 in row 1? Can't be here or here because of 4 is in the boxes, so it's there. Where is the 4 in the central box? Cannot be here or here because of 4 is in the row and column, so it has to be there. The 4 in column 3 cannot be here because of 4's in the boxes, and these are filled, so 4 has to be there. And that gives us 8 4s, so we know where the last 4 has to be. It's there. 3s. We have 3 3s in circles. The 3 in this right central box cannot be here because of 3 in the column, so 3 has to be there. In this lower central box, cannot be here because of 3 in the column, can't be here because of 3 in the row, so it must be there. That gives us 8 3s, so we know where the last 3 has to be. It's there. 2s. We have the 2 2s in circles. And where is the 2 in this upper left-hand box? Cannot be here because of 2 in the column, can't be here because of 2 in the row, so 2 has to be there. Where's the 2 in row 2? Can't be here because of 2's in the boxes. These are filled, so 2 has to be there. Where's the 2 in column 9? Can't be here because of 2 in the boxes. These are filled, so 2 is there. Where is a 2 in this central box, or column 4? Cannot be here because of 2 in the box. Can't be here because of 2 in the row, so 2 is there. That gives us 8 2s, so we know where the last 2 is. It's there. And we don't have enough information about 1s, really? Well, we kind of do. Where is 1 in this upper left-hand box? Cannot be here because of 1 in the column, so it has to be there. Column 2, it's just left there. Excuse me. 1 in this lower right-hand box cannot be here because of 1 in the row, so it can only be there. 1 in column 9, then, can't be here because of 1's in the boxes, so 1 has to be there. 1 in row 9 cannot be here because of 1 in the boxes, so 1 has to be there. In row 6 cannot be here because of 1 in the column, so 1's there. That gives us 8 1, so we know where the last 1 is. It's there. Everything else left is 6 or 8. This has to be 6 because we have an 8 there. That leaves that as 8 there, which means in the box this must be 6. This is 6 8 as a pair. 6 8 as a pair here. This 6 eliminates, this means this has to be 8 here, which means this must be 6. Which means that must be 8, that's 6. 8 eliminates 8 there, so it's 6 and 8. 8 eliminates 8 there, so it's 6 and 8. 6 eliminates 6 there, so it's 8, which makes that 6, which makes that 8. And that's a solution. That was actually a little bit more difficult than I thought a very easy one should be. There's a lot of kind of advanced, more advanced techniques with the counting circles than I'm used to for these counting circles. So I feel like this was kind of more along the easy level. But the thing is, like, it's really hard to find a very easy counting circles puzzle because it tends to be kind of actually complicated. So this wasn't too bad. But I think on the whole, I would classify this as an easy level puzzle. But I hope this made sense and this was easy for you to follow for a counting circles puzzle. They're probably one of my favorite puzzles, but also because I can spot them pretty easily. I think mainly because I've done a lot of Killer Cage Sudoku, and it involves a lot of counting related to that. So, anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.